Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
There's a chance that Yellowstone National Park is sitting on a time bomb. There's a supervolcano underneath the national treasure, Yellowstone National Park. This natural wonder is hiding a seismic secret that's now coming to the surface. There have been hundreds of earthquakes recently, so scientists are keeping a close eye on things. Could this be the start of the catastrophic eruption that experts have been predicting? Or is there something more mysterious going on beneath the geysers and hot springs? Join us as we take a closer look at the recent tremors and explore what they might mean for Yellowstone and potentially the wider world. Something pretty remarkable is going on, and you won't want to miss what the scientists have discovered. Before we look at the recent seismic activity, it's important to understand the context of Yellowstone National Park, which was established on the 1st of March, 1872 by President Ulysses S. Grant. Yellowstone is not only the first national park in the United States, but also the first of its kind in the world, spread over 2.2 million acres in Wyoming, Montana, and Idaho. It's a huge area of wilderness, geysers, hot springs, and wildlife, including grizzly bears, wolves, and herds of bison and elk. But there's more to Yellowstone than meets the eye. It's not just a park. It's a giant volcanic caldera, one of the largest active volcanic systems in the world. This caldera is part of the larger Yellowstone Volcano Observatory, which also includes geysers like Old Faithful and Grand Prismatic Spring. As a supervolcano, it can erupt thousands of times more powerfully than a typical volcano. The caldera is a huge crater formed by the last of 3 super eruptions in the last 2.1 million years. The first of these eruptions happened 2.1 million years ago, creating the Huckleberry Ridge Tuff and leaving a caldera more than 60 miles across. The second eruption, which happened 1.3 million years ago, created the Island Park caldera and the Mesa Falls Tuff. The last major eruption happened about 640,000 years ago, creating the Lava Creek Tuff and forming the Yellowstone caldera as we know it today. This eruption was so powerful that it ejected over 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, causing a global temperature drop and affecting ecosystems worldwide. Just picture a force so powerful it could cover an entire continent in ash, disrupting the global climate and causing widespread destruction. If there was an eruption like that, it could bury cities and farmland. That would have a huge impact on agriculture and infrastructure. The release of sulfur aerosols could cause a volcanic winter, cooling the planet and affecting weather patterns for years. But what if I told you the story doesn't end there? Stick with us to the end to discover the potentially catastrophic consequences of a Yellowstone eruption. It could change the course of human history. Recent studies have revealed something pretty incredible. There's not just one magma chamber beneath this giant volcano, but 2. The first was found in the 1980s and is about 10 kilometers below the surface. It contains around 10,000 cubic kilometers of molten material, but there's more. Between 20 and 50 kilometers below the surface lies a second magma chamber that is 4.5 times larger. This deeper chamber was discovered using seismic imaging, which is a pretty groundbreaking revelation. Together, these chambers contain enough molten rock to fill the Grand Canyon nearly 14 times over. This discovery doesn't mean there's a higher chance of an eruption, but it does mean that the shallow chamber can be replenished over and over again, providing a continuous source of energy for the park's geothermal features. What does this mean for the park? And why is it important? There's a pretty incredible geological show going on at the heart of America's first national park. Yellowstone recently played host to a seismic spectacle that has fascinated scientists and the general public alike. In just 12 hours, the northern part of Yellowstone Lake experienced a series of tremors that caught the attention of experts and the public alike. The sequence started on 28 March with a 0.7 magnitude quake that seemed pretty insignificant at the time. But it was just the start of a remarkable seismic swarm. In the space of just half a day, at least 60 earthquakes were recorded, ranging in magnitude from 0.1 to 3.7. 2 of the quakes were above magnitude 3.0, with the largest being a magnitude 3.7 at 8:24 a.m. MDT. The University of Utah seismograph stations and the Yellowstone Volcano Observatory kept a close eye on this seismic activity. We're still looking into some of the smaller earthquakes in the area. Earthquakes in Yellowstone aren't unusual, making up about half of the total seismic activity in the Intermountain West region. But this recent sequence has sparked new conversations and concerns about the big one that could hit the park. The area is one of the most seismically active in the U.S., with between 1,000 and 3,000 earthquakes a year. Most are small and go unnoticed, but the recent swarm has got people talking. The mere mention of a possible eruption in Yellowstone National Park is enough to send shivers down the spine of anyone who knows about the geological power of the region. To start with, it would be a truly unprecedented event. The area around the park would be badly affected. Lava flows, pyroclastic surges, and ashfall would destroy everything in their path. The lovely landscapes, rich biodiversity, and iconic geysers would be destroyed by the power of the eruption. The human cost would be huge. Millions of tourists visit the park and surrounding areas every year, and nearby towns and communities would be at great risk. Evacuation efforts would be a huge challenge. One model suggests that a super eruption at Yellowstone could affect 3/4 of the US and kill 90% of people within a 1,000-kilometer radius of the blast. One of the most worrying things about a Yellowstone eruption would be the widespread ashfall. A big eruption could send thousands of cubic kilometers of ash into the atmosphere, covering large areas of North America. One map shows that areas as far away as Missouri and Texas could get more than 10 centimeters of ash, while areas closer to Yellowstone could be buried under several meters of it. On top of that, the huge amount of volcanic gases and aerosols released into the atmosphere would have a significant impact on the global climate. Sulfur dioxide and other gases could form a layer of aerosols in the stratosphere, reflecting sunlight and causing the Earth's surface to cool down significantly. One study suggests that a super eruption at Yellowstone could reduce global temperatures by up to 12 degrees Celsius for several years. This could also affect weather patterns, reducing agricultural yields and leading to food shortages in various parts of the world. When it comes to a potential eruption, we need to look at what we've learned from past volcanic events to make sure we're managing and mitigating the risk in the best way possible. But the question is the supervolcano showing signs of waking up? Or are these tremors just the Earth reminding us of its power and unpredictability? To get a handle on this, we need to look closely at the geological complexity of Yellowstone. The park is located on a hotspot, which is a plume of molten rock rising from the Earth's mantle. This hotspot is what powers the park's geothermal features and is responsible for the volcanic activity in the region. It's also one of the few hotspots under continental crust rather than oceanic crust. The recent earthquake swarm near the eastern rim of the Yellowstone caldera, close to the area of the last major eruption, has brought this geological wonder back into the spotlight. Many are wondering if this is the prelude to a more significant event. Seismologists and geologists are looking at the data to see if they can spot any patterns or clues that might show a change in how the volcanic system is behaving. The University of Utah's seismograph stations and the Yellowstone Volcano Observatory have said that the recent earthquakes don't mean there's going to be an eruption soon. It's probably just the movement of fluids and gases under the surface, which is normal for an area like this. The park's geothermal features, such as geysers and hot springs, are not just tourist attractions, but also show how much geological activity is going on under the surface. One example of this activity is hydrothermal explosions. These explosions happen when superheated water that's trapped underground turns to steam really quickly, which causes a violent eruption. At Yellowstone, small hydrothermal explosions, similar to unexpectedly large or uncharacteristic geyser events, occur almost every year and can pose a danger to anyone in the vicinity. For instance, a hydrothermal explosion took place at Porkchop Geyser in the Norris Geyser Basin back in 1989. You can still see the remnants of the eruption as rock debris around the central fountain. The last major hydrothermal explosion created a crater within the park just 3,000 years ago. We also need to be aware of the risk of landslides in the region. The unstable terrain, along with weathering and seismic activity, can cause sudden and catastrophic landslides, blocking roads and trails, isolating parts of the park, and putting hikers and motorists at risk. This geological activity can also be made worse by tremors and earthquakes, which can change geysers and hot springs and cause landslides. As we explore the secrets of Yellowstone further, we can't help but think about one of the most significant seismic events in the park's history, the Hebgen Lake earthquake. Is history repeating itself? The Hebgen Lake earthquake, which had a magnitude of 7.5, was the largest earthquake to hit the area in recorded history. The quake caused some pretty big landslides, including one that blocked the Madison River and created Quake Lake. The landslide was estimated to have traveled at around 100 miles per hour and contained approximately 80 million tons of rock soil and debris. The landslide swept down the Madison River Canyon, and it buried a campground and killed 28 people. The earthquake caused a lot of damage to roads, bridges, and buildings, not just in the area where it happened, but also further away. The earthquake also damaged infrastructure within Yellowstone National Park, which affected visitor access and park operations for some time. The earthquake also had a big impact on Yellowstone's geothermal features. Geysers that had been dormant for decades suddenly erupted, and the patterns and behavior of others changed dramatically. For instance, the eruption patterns of the well-known Old Faithful geyser were affected, and new hot springs and fumaroles emerged in the park. The event led to a rethink of the seismic risks in the Yellowstone region and prompted some big changes in monitoring and preparedness. The USGS and other agencies ramped up their monitoring, and building codes and emergency plans got an update to reflect what they'd learned. As scientists keep digging into the mysteries of Yellowstone, the world is on tenterhooks, waiting to see what else they'll find out. One clue could well be Yellowstone's wildlife. From thick forests to open meadows, from steaming geysers to icy rivers, the park's landscapes are home to a huge variety of plants and animals. But recently, there have been some strange reports from visitors about unusual encounters with wildlife, particularly bison. 2 weeks ago, a woman was gored by a bison despite repeated warnings. In another tragic incident, a woman was found dead on the Buttermilk Trail, 8 miles from West Yellowstone, just last week. Investigators found grizzly bear tracks at the scene, which suggests that this was a fatal encounter with a bear. The area has been closed until the 25th of August for safety reasons, both for people and bears. The investigation is still ongoing. It's not yet clear if there's a link between the animal's behavior and the recent seismic activity. Some experts think the animals may be sensing something that we can't. After all, these animals have lived in harmony with the land for thousands of years. The idea that animals can sense seismic activity before humans isn't new. There are cases where animals have shown unusual behavior before earthquakes. For example, dogs have been known to bark excessively or cats to hide. In Yellowstone, the link might be even stronger. The park's geothermal features and seismic activity are part of the natural landscape, and wildlife has adapted to these conditions over millennia. The bison in particular have a strong connection to the land. They use the park's geothermal areas in winter to take advantage of the heat, and their migratory patterns are influenced by the geological features of the region. Could the recent changes in behavior be down to shifts in the underground magma chambers? Could the animals be reacting to vibrations or chemical changes in the environment that we can't perceive? These are the questions scientists are now looking into, trying to find links between animal behavior and seismic data. The way animals behave, the flow of rivers, geysers erupting, and earthquakes rumbling are all connected in ways we're only just beginning to understand. Given the region's geology, there's a real risk of earthquakes and volcanic eruptions. That's why officials are working hard to understand, monitor, and mitigate the potential risks. The new Yellowstone Volcano and Earthquake Monitoring Plan, put together by the Yellowstone Volcano Observatory, YVO, and other partners, is all about improving monitoring and hazard assessment in the region. The plan includes detailed descriptions of existing and planned monitoring systems, focusing on 2 main categories: backbone monitoring and hydrothermal monitoring. Backbone monitoring is the name we give to the existing region-wide monitoring network that has been set up to keep an eye on seismic activity, ground deformation, and other geological phenomena in the Yellowstone Plateau region. The network includes seismometers, GPS stations, and other instruments placed throughout the park to provide real-time data on what's going on underground. The plan is to expand this system over the next decade. We're also going to be monitoring Yellowstone's thermal and geyser basins as part of the plan. We'll be keeping an eye on things like temperature, pressure, water chemistry, and other parameters in the thermal and geyser basins. It'll give us great insights into how the hydrothermal system behaves and help us spot any unusual changes that might signal an impending geological event. The University of Wyoming, along with other scientific agencies like the U.S. Geological Survey and the National Park Service, is playing an active role in this monitoring effort, which shows how important it is to understand and deal with geologic hazards in the Yellowstone Plateau region. The data from these monitoring systems will help scientists predict potential eruptions or earthquakes, and it'll also improve public safety and preparedness. While there's been some recent seismic activity in Yellowstone, it's important to remember that the likelihood of a supervolcanic eruption in the near future is still very low. Experts say there's less than a 1 in 730,000 chance of a supervolcanic eruption happening in our lifetime, but it's important to keep an eye on things to understand what's going on under the park and to spot any big changes early. The Yellowstone Volcano Observatory and other research groups are working hard to share accurate, up-to-date information with the public so that people know what to look out for without getting too worried.